More of these triangle parallelogram questions. Let's look at our Z here. We have alternate angles here. A is equal to 31. And we're looking for B. If we take this triangle and we can see these two are the same, which means the angles, this angle and this angle have to be the same. So A is equal to B. So B is also 31 degrees. And the last part of this, the diagonals bisect the angle, so that means that that's C there as well. So with this one we can say that 2C would have to be equal to 180 take away A and B, so 180 take away twice 31. So 2C is equal to 62,118. So C is equal to 118 divided by 2, which is 59 degrees. Now question 8. The thing you did hopefully before this topic was coordinate geometry, where you learned how to plot points and you looked at slope, you looked at midpoint, and you looked at length of a line. So here it's going to come in handy in question 8. So you need to draw a coordinate diagram in your copy. You can see the highest value on Y is 7, so you need to go up 7, and X, the highest value is 5, we need to go out 5. So something along these lines, and we did need to go to 7, so I'm going to put a 7 in. So let's put our points on. So we've got 1, 2, 2, 5, 1, 2, 2, 5. Then we've got 5, 7, and 4, 4. 5, 7, and 4, 4. I'll just put back in my 1, 2, my 2, 5. So what have we got here? Well, it looks like we have a parallelogram. So let's check the slopes. So the slope of this line is positive. You can see the rise is 3 over the run, which is 1. So the slope of this line is 3. The slope of this line here, my rise is 3 and my run is 1, so the slope of this line again is 3. Just take these out. What about the slope of my black lines? My black lines, my slopes are, the rise is 2 over the run, which is 3. So the slope of this line is rise over run 2 over 3, and you can see the rise here is also 2 and the run is 3, so the slope of this line is 2 over 3. So let's go back and see what they were asking us. So we found the slopes, they were the same. And we found the other slopes and they were the same. And explain, so we did these two, we got 3 and 2 over 3. Explain with reference to the slope how to show that ABCD is a parallelogram. So we could say here that opposite sides have the same slopes, and opposite sides are also equal in length, so ABCD is a parallelogram. And to explain two methods you could use to determine if ABCD, if it's a rhombus, well, all sides would have to be the same length. If it's a rhombus, we saw that in a previous video, and you can tell by the slopes here, even by looking at them, that they're not the same length in this case, but that's how you would determine whether it's a rhombus. Also, for it to be a square shape, the diagonals would have to intersect at 90-degree angles, which in this case you could clearly see isn't the case. And to prove it, you just say 3, the slope, by 2 over 3 is not equal to -1, the product of the slopes, to get 90 degrees. So that's question 8. Question 9. Bringing in sets, you can see here. So they can mix up these questions. The Venn diagram shown represents all possible quadrilaterals. A is the set of all rhombuses. So we just need to know what a rhombus is. B is the set of all rectangles. And describe in words the type of quadrilateral that is described in each of the following cases. So A union B. A union B is the set of all rhombuses and all rectangles. So all I think you can say rhombi. All rhombi and rectangles is the two of them. A intersection B is where they're squares. B less A, so in here, and B is all rectangles, so the rectangles that are not rhombuses. So in this area we have rectangles. In the middle bit we have rectangles that are squares, and we have rhombuses that are squares. So we have rectangles that are not squares in B less A. I'll just write S for squares, SQ. A less B, well, A less B is going to be rhombi or rhombuses that are not squares, the middle part. Rhombi that are not squares. And then A union B complements. So what's out there? All other types of quadrilaterals have to be out there. So what's outside A union B? Quadrilaterals? Quadrilaterals that are not the other two, rhombuses or rectangles. So other types of parallelograms, trapeziums and stuff like that.